Section 5.4. We're looking at the fundamental theorem of calculus. Now that I've gone through it once with you, let's see if our answers match up. What does this represent geometrically? Your answer is area under the curve. Which curve? F of x. So when I come down here and ask you, if we're going to do this graphically, what am I going to graph? The integrand or the antiderivative of that integrand? What did you say up here? This is the area under what curve? F of x. So I'm going to graph the integrand because f of x is the integrand. Okay. From A to B, and then this is the same thing as, this is the antiderivative, and so I'm going to find the antiderivative first, and then I'm going to put the upper bound in, subtract, same antiderivative, and put the lower bound in. So I have to know what the antiderivative is. The alternative is going through the limit definition, which is a lot of work. So let's go over here. We're going to put in here then x minus 2. And we want to integrate from negative 1 to 0. So probably need to change a window so we can get just that much in here. And if I want to go from negative 1 to 0, I'm going to go negative 1/2 to 1/2, and I can scale by 1. Yeah, negative 1/2 to 1/2. So I'm going from negative, oh, you're right, how about negative 1.5? Is that what you're telling me, Molly? That would be better. That would be much better. Okay. And let's see, if I'm going from negative 1, if I put that into my function, I should have a negative 3, so I need to have, let's say, a negative 4 to a negative 2, so I'm just going to put a 1 in there, and we'll scale by 1. So I put 0 into the function, I'll get negative 2. I just want to see the origin there. So I end up with this quantity right here. Now I'm wanting to integrate from negative 1 to 0, and so if I look at, and we'll just do analyze graph. Now remember, you don't have this when it comes to the press to test. So just be very aware that you don't have this feature when we do press to test. So our area should be negative 2.49. Again, if it's below the input axis, it will be a negative quantity. Okay, so we know what answer we should be going for. It may not be exactly, it may be negative 2.5, but at least we know we'll be in the ballpark. So let's use our analytical work here. And the first thing we have to do is to decide what is the antiderivative. So we have the integration from negative 1 to 2 of x minus 2 differential x is, thank you, is, now what is the integration of x? It's been a while maybe since we've talked about this. Our rule is that we're going to add 1 to the exponent and divide by the new exponent. So this would be, and I'll put this work down just so we can see it in case anyone is needing to see that. Add 1 to the exponent, divide by the new exponent, minus, okay, and divide by the new exponent. Now, here's what we need to do. I'm going to ask you always to put that inside brackets. And then what we do is we use a vertical line to say that we're going to integrate from negative 1 to 0. Okay? Now all we've done is to write out what our antiderivative is. So let me put this in what terms you have, I'm sure. and then integrating from -1 to 0. We have not now, we've not taken care of this piece yet. Another way of writing this would be to say that it's f of x integrating from a to b. That's the equivalent of what we just did. Now, what we need to do, though, is to use the inputs. So I need to put the upper bound in first, find the value of the antiderivative at the upper bound, and then subtract, subtraction's there, and then subtract when I put the negative, the lower bound in. So we then end up with this. I'm going to put these in brackets. This would be 0 squared divided by 2 minus 2 times 0. Now this is f of 0 minus, that is a capital F. It doesn't look like, I meant it to be a capital F, and I let that one piece drift over. Okay, so f of 0 minus f of -1. So this is going to be -1 quantity squared divided by 2 minus 2 times -1. This middle line would be a good idea to put in. I've just inserted it right there so that you understand you're doing f of 0 minus f of 1. Now, what did I forget in the antiderivative? Plus c. Plus c. Oops, let's do both of these. Plus c. Plus c. So when I come down here and I look at this work, I actually have a plus c on each of these. Now I'll tell you why we kind of drop that plus c at this point. When we are subtracting, what happens to the c's? They cancel out. Yeah. So when we do antiderivatives, we really don't even bother with those because we understand that they drop out. On the indefinite integrals, you got to put it there because we don't have a specific problem. We're not finding the area between, under the curve and all that. But when we get to this, the c's are there, but when we do the subtraction, they cancel out. Okay. So let's see, this is going to be actually 0 minus, and this is going to be 1/2 plus 2 or simply -2.5. What did we say in our graph that it should be? Yeah, and I said you got to take those with caution. They may not be exactly, because what we're doing is we are estimating. We think we're at -1 and we think we're at 0. Okay, so be cautious with that. Don't take these answers as absolutes. Okay, what do we do? Well, we first found the antiderivative, okay, with the rules that we know from section 5.1. We then use the upper bounds and the lower bounds. We put those in and we evaluate. That's all there is to it. A lot simpler than finding the limit of the summation of the areas of rectangles. Okay, let's try this one. -8 to 1. Now again, keep in mind, this is before 5.5, so there's no substitution to worry about. Think about using some simple integration rules. And so I'm thinking from -8 to -1, how can I simplify this? Now I'm going to take the cube root as x to the 1/3 power. And then if I take, and I'll write it out here, if I take this and write it as two separate fractions, I have x divided by 2x to the 1/3 power minus x squared divided by 2x to the 1/3 power. So it's a little bit of work just to kind of maybe clean it up to get ready for this, but I see this as 1/2 x to the negative 2/3 power, minus 1/2 x to the, let's see, that wouldn't be negative 2/3, would it? That'd just be 2/3 power here. 1 minus 1/3 is 2/3. 6/3 minus 1/3 is 5/3. Okay, I'm still not ready until I haven't taken the antiderivative yet. But here we go. This is going to be 1/2. And this will be, let's see, x to the 2/3 plus 3/3 is 5/3, divided by 5/3, minus 1/2 x to the 5/3 and 1 would be 8/3, divided by 8/3.